Hey everybody, so today I'm going to be talking about the Vendortron 9000. The purpose of this robot is to provide a fun and efficient way to be a store kiosk and an amusement park in this situation that can provide goods to customers with the push of a button. The robot itself has two DC motors that control its wheels. The robot sits on a rail system, allowing it to move left and right, and we'll see how that interacts with how it's going to decide the proper product to use. Along with that, it has two servo motors, one for the body position and one for the arm. When the body position is in the 180-degree position, it's going to be facing away from the customer and towards the goods and services behind the counter. The arm itself, when extended 180 degrees, will extend out, grab the product, come back to a 90-degree position without releasing. From there, the robot will turn back around with the body servo, find the home box, and then fully retract the arm to the zero position to drop the good inside the box for the customer to retrieve. So as we watch the simulation go, we use photodiodes here to simulate the light that would be telling the robot where to go. For the code itself in our monitor, we'll be setting it to a value associated with whatever product is going to be. In this situation, we'll set it to the value of 84, which translates to item number 1. So from there, if we hit 1 for the selection, you'll see the body servo turn 180 degrees, and the robot will look for the product. The product was right behind it. The arm has grabbed it 180 degrees. From there, the body goes back to the zero position, and the arm goes to the 90-degree position, and it's waiting for its signal to go back home. In this situation, since it is right behind the box, we'll say hit 0 for return, and from there, if you watch the servos, you'll see the arm release the product into the box. Now, if it wasn't there, we'll set it to product number 2, which is set to value 83 in the code. We'll go through the code a little bit later. You'll see the body turn. From there, you'll see the motor start spinning, and it's searching for the product itself. It's searching for the 83 value that corresponds to product number 2. And it's going to run, delay for 5 seconds, and then move again down the rail trying to find the right product. We'll simulate this by going to the right product number 83, and we'll run it. And from there, you'll see the robot will find the product, go to 0, arm will extend, and then the body rotates back around 180 degrees with the arm in the 90-degree position. Now, if I have the home sensor set to 0, so it's not in front of the box, and the robot goes back home, you'll see the motor spin in the opposite direction, once again searching, 5-second delay in between, looking for the home box until it sees it. From there, once it sees that home signal, the robot will stop and release the arm. The code here is written to the right here that uses the IR receiver in order to control and act as the keypad that a customer would select for the product. It'll run through a case switch scenario depending on what button is pressed. In this situation, I have 3 items listed. It can be expanded to more items if needed. To search for the item here in my if statement, if it does not equal the right light sensor, and if it does find it, it will stop our motors and extend the arm, retract the arm, and then turn the body back around, ready to go back home. The final case in the situation, case 0, is its home sequence, where it'll search for that light sensor. Once it does, it'll stop all motors and then fully retract the arm. Otherwise, it'll keep going in the reverse direction until it finds the home box, where it can deposit the item. I'll scroll through the code one more time. And that is the code. I appreciate y'all for watching. I hope you enjoyed it.